This is lesson 7.1, Zero and Negative Exponents. Your objective is to simplify expressions involving zero and negative exponents. You can extend the idea of exponents to include zero and negative numbers. Zero as an exponent. For every non-zero number a to the 0 power equals 1. For example, 4 to the 0 power equals 1, negative 3 to the 0 power equals 1, and 5.14 to the 0 power equals 1. Negative exponents. For every non-zero number a, an integer n, a to the negative nth power equals 1 over a to the nth power. For example, 7 to the negative 3 power equals 1 over 7 to the third power. Negative 5 to the negative second power equals 1 over negative 5 to the second power. We cannot use 0 as a base with zero exponents. 0 has an exponent property that implies the following pattern. 3 to the 0 power equals 1, 2 to the 0 power equals 1, 1 to the 0 power equals 1, which would mean 0 to the 0 power equals 1. However, consider this pattern. 0 to the third power equals 0, 0 to the second power equals 0, 0 to the first power equals 0, which would imply 0 to the 0 power equals 0. It is not possible for 0 to the 0 power to equal both 1 and 0. Therefore, 0 to the 0 power is undefined. We cannot use 0 as a base with a negative exponent. Using 0 as a base with a negative exponent will result in division by 0, which is undefined. For example, if you look at the negative exponent's definition, if I have 0 to the negative 3 power, that would mean 1 over 0 to the third power, and we cannot divide by 0. Here's a problem. What is the simplified form of each expression? We have 9 to the second power. 9 to the second power means, by definition of a negative exponent, I can rewrite this expression as 1 over 9 to the second power. Once you rewrite it, you can simplify it as 1 over 81. Negative 3.6 to the 0 power is always equal to 1, by definition of 0 as an exponent. Let's try this problem. We have 5 times a to the third power times b to the negative second power. B to the negative second power implies that it's equal to 1 over b to the second power. So I can multiply 5 times a to the third power by 1 over b squared. And that simplifies to 5a cubed over b squared. Here we have a negative exponent in the denominator. We have 1 over x to the negative fifth power. This really means I'm taking 1 divided by x to the negative fifth power. X to the negative fifth power means 1 over x to the fifth power. In order to divide by a fraction, we have to multiply by the reciprocal. So we rewrite this as 1 times x to the fifth power, which really equals x to the fifth power, the identity property of multiplication. When you evaluate an exponential expression, you can simplify the expression before substituting values for the variables. For example, what is the value of 3s cubed t to the negative second power for s equals 2 and t equals negative 3? Method 1 is to simplify the expression first. We have 3s to the third power, which we can leave alone, but t to the negative second power means that has to go in the denominator, so we rewrite it as 3s cubed over t squared. Now we can substitute s equals 2 and t equals negative 3. Once we do that, we can simplify the numerical expression to 24 over 9. The other method is to substitute first. So we can substitute 2 for s and negative 3 for t. Once we do that, we can rewrite the negative 3 to the negative second power as negative 3 to the second power in the denominator, then simplify it, and we'll still get the same answer. Here's a word problem. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1000 times t to the h power, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h equals 0 and h equals -3. What does each value of the expression represent in the situation? So first we'll substitute h equals 0, and 2 to the 0 power equals 1, so our expression equals 1,000. The value of the expression for h equals 0 is 1,000. There were 1,000 bacteria at the time the scientists measured the population. Next, we'll substitute h equals -3. Well, 2 to the -3rd power, I can rewrite as 1 over 2 to the 3rd power, which is equivalent to 1 over 8, and when I multiply it by 1,000, it equals 125. The value of the expression for h equals -3 is 125. There were 125 bacteria 3 hours before the scientists measured the population. Here are some sample problems for you to try. What is a simplified form of each expression? First, we have 4 to the -3 power. I can rewrite this as 1 over 4 to the 3rd power. Well, I can simplify 4 to the 3rd power as 64, so I can rewrite this as 1 over 64. Any number to the 0 power is always equal to 1. Let's try these with the variables. We have 1 over n to the -3 power, which really means 1 divided by n to the -3 power. Well, n to the -3 power really means I'm dividing by 1 over n cubed. Sorry about my exponent. Well, dividing by a fraction means I multiply by the reciprocal, which means I'm taking 1 times n to the 3rd power, and that will equal n to the 3rd power. Here we have 4 times c to the -3 power times b. Since this is the only one with the negative exponent, I need to rewrite that. I need to rewrite that using the definition of negative exponents. So this expression will become 4b over c to the 3rd power. Here we have 1 over n times w to the -1 power. Be careful here. The -1 power only applies to the w and not to the n. So I'm going to use, I'm going to simplify first. I'm going to use method 1. So I really get w to the 1st power, which is just w, over n. And then I will substitute my values, which is 5 over -2. And that'll just equal -2.5 or -2.5. The other method is to substitute first and then simplify. So I can do 1 over -2 times 5 to the -1 power. Well, that just means the 5 to the -1 power, we're dividing by that, so we're really multiplying by the reciprocal of 1 over 5 to the 1st power, which is just 5, which means we're really multiplying by 5. So I'm just going to rewrite this. So we're, oops, sorry, I'm going to rewrite it. And we should get the same answer. As before.